Now, I warned you that was going to be really complicated. So let's look at it one more time from a little different angle. In our population, each unit has a value of a bunch of different variables. I'm going to call their pre-treatment variables. And they also have a value of the instrument. So let's write those down. We've got their pre-treatment variables. And the instrument. Now, there might be some causality going on between the instrument and the pre-treatment variables. So let's draw some arrows here to indicate that the instrument might affect the values of the pre-treatment variables and vice versa. Now, once these things are determined, both the value of the instrument and the value of their pre-treatment variables are going to determine what the value of their treatment variable is. Now each unit has a value of the instrument, value of their pre-treatment variables, and what their treatment variable is. Now all of these variables together then are going to combine to determine what their outcome is. The treatment, the instrument, and the pre-treatment variables are all possibly going to affect the particular value of the outcome that any unit gets. So now what do we want to know? We want to learn the causal effect of treatments on outcomes. This arrow right here, the causal effect of treatment on outcome. When we go to our data, we can't just look at the correlation between treatments and outcomes and say that's the causal effect because of these other variables, the pre-treatment variables, for example. Those are possible confounders because they affect the treatment and the outcome variable. And moreover, these don't have to be observed by us. Many of these variables could be unobserved confounders. So we don't even have them in our data set, and we can't even do something like a regression analysis where we condition on these pre-treatment variables and only look within subsets of people. We can't do that because they might not even be observed. So there's a whole bunch of confounders out there that could be driving a correlation between treatment and outcomes and causing this whole correlation is not causation problem. So what are we going to do? Well, that's where the instrument comes into play. We look at not the correlation between treatments and outcomes, but between the instrument and outcome variables. Now, why might there be a correlation between the instrument and the outcome? Well, there's three possible reasons. The first is that the instrument might have a direct causal effect on the outcome. That's one possible path from the instrument to the outcome. That could explain why we see this correlation. But no. Because in step 2, we assumed that that was not the case. So this arrow here cannot happen. There cannot be a direct effect of the instrument on the outcome. Another possibility is that the instrument might affect some of the values of the pre-treatment variables, which in turn affect the outcome variable. So that's another possible path from the instrument to the outcome. But that also cannot be the case, because the instrument is randomly assigned, okay, which means that it's not related to these pre-treatment variables. So these paths also do not exist. That leaves but one possibility, that the instrument has an effect on the outcome variable through the treatment variable. That's the only path from the instrument to the outcome. And that means that any correlation we see between the instrument and the outcome must be picking up the combined effects of the instrument on the treatment and the effect we want to learn, the treatment on the outcome. So we're not quite done yet, because that correlation between the instrument and the outcome isn't exactly the effect we want, the treatment on the outcome. It's the combined effect of the instrument on the treatment and the treatment on the outcome, these two arrows. So we have to somehow remove this first effect. Well, we can do that because of step 5 here. Because the instrument is randomly assigned, all we have to do is look at the correlation between the instrument and the treatment in the data, and that's going to tell us what this first arrow is, because that's just an ordinary experiment. So once we do that, we know what the first arrow is, we know what the combined effect of both arrows is, and that information alone is enough to deduce what this last arrow is, just the effect of the treatment on the outcome. And that is the essence of instrumental variables analysis. So how does this work in practice? In practice, you've already got the data sitting on your computer waiting to be analyzed. You see the treatment variable, you see the outcome variable, and you see a whole bunch of other pre-treatment variables. Now, among all of these other variables, you're going to search for one special variable that you're going to pick out. That's called the instrument. Now, why is that variable special? Because you're going to try to argue that these three assumptions hold for that variable. Once you've done that, you can apply the logic that we just talked about to use that instrument, that special variable, to get at the true causal effect of the treatment on the outcome variable, which is what you really want to know.